Is sharp. Asking. You guys are never happy with anything. This is what. Because his doesn't have a little spaceship. Ever your people are looking on?
I like your setting.
Hey guys, we'll get started here in just a second. Just a reminder, put your name in the chat if you haven't already, so I know who's in here.
Miss Jennifer?
Uh-huh.
I just wanted to let you know that I'm here because my chat doesn't work.
Ah, gotcha.
Okay.
Hey, Elliot, you might want to mute.
All right, there's just a couple that I'm looking for. Mason, are you in here? Mason Gore, are you on yet? I don't see you on here. And I'm looking for Chanel. Chanel, are you on yet? Dalton? All right. We'll give him another minute or so and then we'll get started. There's Mason.
Mom, who's in?
All right. Looks like we're missing Chanel, Dalton, Brantley. I don't see Brantley on here. Lucas. I got you, Drew. We'll see if they show up. So welcome back. It's a new year. You are officially to the second semester of STEM Squad already. Do you believe that it's already been that long that you guys have already been in STEM Squad for a semester? So we're officially starting the second semester here right now. So Miss Sarah gave me something pretty cool a little bit earlier. STEM Squad shirts came in. So those are pretty cool. So if you got one of those ordered, I'm not sure if Miss Melissa's planning on giving it to you guys next week or not. But she's on a cruise right now. So she's like in all kinds of tropical weather today. And here we are in the cold and the wind and the rain. But you'll have to ask her about that whenever you guys see her next week when she comes back. So just one final check-in. Make sure I didn't miss these people popping in. Chanel, are you in here? Dalton, pal. Don't see Dalton. Brantley, and Lucas. All right. Well, anybody have any ideas what this month's topic is about? Hopefully you've been looking some things up about the topic that Miss Melissa emailed you about, because it has changed from the original layout that we had. So originally she had planned on doing something different this month, but we changed it up a little bit. You guys are right. It absolutely, it is Mars is our topic. But before we get into that, before we get into all those Mars facts, how many of you did your reading for this month? So what you were supposed to do this month was chapter 7 through 9. So we're actually getting into where he's actually becoming an astronaut and going out into space. So we're just going to go through a few questions that we've got. And you can raise your hand to answer the questions, okay? So, or you can write your answer in the chat. Either one, perfectly fine. So let's see here. All right, so first up, our first question. If you remember in the reading, so Scott had moved down, started doing all of his astronaut training. He was testing and training in all of the simulators, but he didn't quite consider himself a full-fledged astronaut. Does anybody remember what it was that he said would happen and he would consider himself an actual full-fledged astronaut? Ooh, I see a few answers here. Ooh, I see some hands too. So let me see here. The first hand I have up is Arya. What's your thoughts on that? Do you know?
He said that he'd be a full-fledged astronaut when he went into space.
So when he actually left Earth's atmosphere and went into space, that's when he would consider himself, and a lot of astronauts too, when they would actually consider themselves a full-fledged astronaut. Because believe it or not, there are some astronauts out there that never have gone into space. They never got called up. They never went into space. So that just makes me wonder, do you think they consider themselves astronauts still? I'm sure they probably do. All right. Question 2. What do you imagine has changed about the astronaut training since when Scott was training back in the class of 1996? Do you think astronaut training would be the same, or do you think it would be a little different? So what are your thoughts on that? Drew, I see your hand up. What are your thoughts?
I think that there'll be a lot of similarities, but maybe there'll be more training for like going to the space station because in 1996 the space station hadn't been finished yet, and so people weren't really trained for really, really, really long times in space, perhaps.
All right, good thoughts. I like that. Yeah, because back when he was doing his training, was the space station finished yet? Not yet. So that was actually part of some of the missions that he was going on. He was going on to do things like that. I've got Emery's hand up. Do you want to share?
I think there would be more safety precautions. This stuff would be a lot safer, like the rocket
Definitely.
training.
I see some other people said that in the chat too. Like Emma, she said she thought it would be more precautions. Because since then, obviously, technology's changed a lot, right? So even technology's changed. And they've learned things since then too. Eliza said different because technology has changed so much. Yes, definitely. Let's see who else. Aria, I see your hand up there. Do you have some thoughts, Aria? All right, let's move on to the next question. So if you remember when he was getting ready to go up, there were tons of delays, delay after delay after delay. He ended up being quarantined for days on end, for weeks they were up there, and they finally got to go up. Do you remember what some of the causes for the delays were? Does anybody remember those? Nick, I see your hand just went up. Do you remember what any of the causes were?
I think one of the causes was like it was really cold outside, and it was hard for them to launch in cold weather.
Yeah, that was definitely part of it. Weather, usually when a launch is delayed for whatever reason, almost always it's weather related. Because they learned a lot from the Challenger accident. Obviously, if it's too cold, they definitely don't want to launch. So definitely weather related. Y2K, I see Drew said Y2K definitely. So that was right around the turn of the century. And Y2K was a huge thing then. Everyone was just scared that all the computer systems were going to shut down and life as we know it was going to be completely different. They did have some delays, they thought, for Christmas, but did that end up happening? Did they actually get to stay home for Christmas? No, they didn't. They actually had to stay and they went on up. So they also had an issue with the mission right before them. Does anybody remember reading about that? So the mission that was up right before them, they had an issue with that. That was a huge cause of delay. Anybody remember anything? If you do, you can go ahead and unmute.
It blew up.
Not that one. Luckily, that one did not blow up. No, that they made it home safely, but they did have some issues up there. So they had some issues with. Oh, go ahead.
Okay.
Oh,
Wasn't it when there was a Dragon cruise ship that was going to take supplies to the International Space Station, and it didn't make it. Like, with the supplies.
Well, if you look at Chanel's answer there, she kind of put it in there. There was some faulty wiring, which was rubbing, causing some sparks and things like that. So they had to basically rewire a lot of the shuttles, not just the shuttle Scott was going up on, but a lot of the other shuttles too. So lots and lots of delays. I mean, that's just kind of part of being an astronaut. And if you guys ever go down to Florida and want to watch a launch, you're probably gonna be this lucky to actually get to watch it on the day it's supposed to launch. There's usually just tons and tons of delays. All right, let's see here. What's up next? So once he was sitting on the launch pad and they were ready to go up, if you remember, he said, boy, this is a really dumb thing to be doing. But he said he wasn't scared, right? Do you think if you were in that situation, you would be scared, right? And how do you think that him being concerned for his safety was different than actually being scared? What do you think? Oh, I see lots of yeses. I think lots of yeses too. I would definitely be scared. I would definitely be scared. So what do you think the difference is? Being concerned for your safety and actually being scared. Do you think those things kind of go hand in hand? Aria, what do you think? I see your hand up.
I think that I would not be scared, though I would be concerned for my safety, because it's, I feel like the power of joy and like you actually made it to doing it would overcome being scared, and I think it would just be really cool to see that you had made it all that way.
Definitely. I definitely think that's true. And I like what Drew just said there. It's different from being scared because he trusted his mission crew, not just his other astronauts, but he trusted the thousands and thousands of people that got him there on that rocket. So that's a big deal. Being scared of something's healthy. It's okay to be scared of something. That's natural. You should be scared. But you should also kind of have some trust in doing things that get you really, really scared too. You want to have a little bit of trust built up in those things too. All right, and our last question. Scott describes survival training in Russia. So if you remember, he got called over to Russia. He was training with Russian cosmonauts. And they were doing a lot of team building, very similar to what the astronauts do here on Earth. Here in the United States. They do a lot of team building. So they go out and they do all this wilderness training and things like that. So why do you think team building is important? Why do you think that was an important thing? Each one of them obviously has their own thing they have to do on a mission. Kenny, what do you think? I see your hand there.
Well, I think that it was important that they I think it was important that team building was so important because if there was an emergency, they would have to use teamwork to fix that emergency.
Okay, definitely would have to have some teamwork in order to get any kind of emergencies taken care of. To be able to communicate better, that's a huge thing. So even though they're doing their own work, doing their own thing, they have to communicate with one another. That's a huge thing. And living with other people. Do you think that every astronaut that goes up there likes each other? Probably not. Probably not. There's probably some differences in opinion, but you got to trust each other. Will, I see your hand up. Did you have some thought?
So they could build trust in life-threatening situations.
Definitely. What are you thinking, Mason? I see your hand up too.
I think because if they didn't have each other, if it was just a one-person shuttle and something went wrong, they wouldn't all be able to fix it because there wouldn't be anybody there.
Okay, good idea. Let's see. I've got Bennett's hand up. What are you thinking, Bennett?
Oh crap. Okay, it was comparing different knowledge of different agencies can also help in situations. Like, oh, I don't know this, but I know this, and oh, I know what you don't know, but I also don't know what you know.
True, because
Just
if you
combines
remember,
it.
he said that the Russians didn't do all the same things that we do over here to train our astronauts. So things are different ideas, better ideas in some cases. Sometimes you can learn things from other people, even if you have more experience. They may give you an idea of something a little bit better. So obviously, team building will be a huge part when we get to go to space camp in the fall too. So keep that in mind. All right, so for our next virtual, so you don't have to have this read obviously by next week. But for the next virtual, I believe Miss Melissa wants you to read the next 3 chapters. So but that's not for next week. Don't panic and think you have to read that for next week. That'll be for the next virtual meeting, which won't be until February. So you'll have at least that long. You'll have until February to get that done, the next 3 chapters. So I think the book's just going to get better and better from here. So we're starting to get into him getting into space and his actual missions. Eventually, we're going to get into his year-long mission up there on the space station, which just blows my mind. I still think that's incredible that he was able to go up there and stay that long. And some things that he'll have going on with his twin brother, Mark, too. All right, guys, let's switch our gears here and get to talking about our topic for this month, Mars. So I'm guessing there's probably a few of you. Have any of you been to Mars camp? Any of you guys been to Mars camp? If you guys want to come, that'll be happening this summer. 3-day Mars camp. It's pretty fun. We get to build a whole Mars colony, all that cool stuff. So keep that in your mind. But so Mars, right? So we're talking about Mars, thinking about Mars. What is the size of Mars compared to the Earth? Bigger, smaller, about the same? Because out there is one that's kind of considered more of a twin as far as size goes. Is it Mars or no? What do you think? Let's see here. What do we got going here? Oh, I see smaller. See some smaller, a little bit smaller. I see Emery says she thinks it's about half the size. Oh, and Meredith got it. Venus that's our sister planet. Venus is the one that's very close in size to us. And you're right. For those of you that said it's about half the diameter, half the size of our Earth. So definitely smaller. So for those of you that were able to look at the Mars facts, here they are again. So it's about half the size, but then it also only has about a third the gravity of what we have here on Earth. So what do you think that's going to mean for the astronauts? Do you think when they go up, they're going to float? If they're walking around on Mars, are they going to float? Eli, are you saying yes? You think they're going to float? I see your yes. Oh, you think yes. All right, so, okay, let's put this in context then. So we know it's got about a third the gravity of the Earth. What about our moon? What's its gravity compared to Earth's gravity? Any ideas? Mars is about a third. You can unmute and answer too if you think you know the answer.
The
About a half?
It's 3/8 gravity.
1/6.
1/6. So for those of you that said it was 1/6 the gravity, you're right. Now think about this. Think about the videos that you've probably seen of astronauts walking across the moon. Did they float? Were they floating? They weren't floating, but if you've ever seen the videos, they're kind of jumping. Kind of looks like they're hopping because the gravity's not as strong. So which one has more gravity then? The moon or Mars? If the moon's a sixth of the Earth, and if Mars is a third, which one has more? Mars, right? It has about twice the gravity that what you'd have on the moon. So definitely would not be floating, unfortunately. So if you have aspirations of being one of those astronauts going up there, you're not going to be floating. but the gravity's not as strong. So do you think it'll be easier or harder to launch things from Mars? So if we in the future are able to build a colony there on Mars, do you think that would be easier or harder to launch things from there? Easier? I see easier, easier. Nick, why do you say easier?
Well, I think it'd be easier because since it has less gravity than us, it won't take as much fuel to launch it into the air.
Okay, so there's not as much gravity. So think about when you're launching things, what are you working against for the most part? Gravity, right? So you don't have as much gravity pulling you down, so it'd be easier. Now think about landing things though. So they've sent tons of things to Mars, landed tons of things on Mars so far. How do you think that affected it with the gravity not being as strong? Aria, do you have an idea? I see your hand. What do you think? With the gravity not as strong, how do you think that affected landing things on Mars?
Well, I had an answer. My hand was still up from the answer for before because I feel like it having less of an atmosphere would have a little bit of a cause on easier to send things up into space.
Okay, definitely. Anybody have any ideas? Colin, do you have an idea? What do you think? How do you think it would affect, the gravity would affect landing things? Do you have any ideas? Anybody have an idea that wants to share? You can unmute if you do.
Because
it
of the
would-
different amount of gravity than Earth, scientists have to find a way to compensate for it.
Yeah, like how they use like bouncy balls. They put it like over the rover, and like it would bounce until it stopped in its position, and then it would open up, and then the rover would come out.
Okay, so they actually used on some of those, they used what are called Kevlar balloons. So Kevlar, have you ever heard of that before? Think about police officers in their bulletproof vests. Those are made of Kevlar. Kevlar is super, super, super strong substance. So they basically made these huge balloons that would go around the rovers. Obviously, if it's a balloon, it's going to what? It's going to bounce a lot, right? So it would make it probably a little bit harder because you wouldn't know exactly where it was going to end up, right? So let's see, Drew says he thinks it's harder because there's a thinner atmosphere, so the parachutes wouldn't work as well. So different from landing things on Earth, so you would have to compensate. Definitely. So yes, and it is. Kevlar is very, very, very strong. Very, very strong. All right, so it also says there that the atmosphere is 95% CO2, which we know is carbon dioxide. What are you going to have to do to compensate for that carbon dioxide being what we have most of in the atmosphere? Any ideas? Any thoughts? All right, Will, what do you mean by air tubes?
Like what they use for like scuba divers, like kind of like those.
Ah, so like tanks, air tanks, oxygen
Yeah.
tanks. You
Yes.
definitely need to have some of those. So if you were going out on a spacewalk, if you were going out of the colony, definitely have to have that.
Yep.
Any other ideas? What do you think that would also play a look at the temperatures. Look at the temperatures there. And think about having an atmosphere that was 95% carbon dioxide. So if you left the colony, so if you went outside the colony, the hottest it's going to get on Mars is around 76 degrees. Now that's a beautiful day here on Earth. But think about that 76 degrees. That wouldn't mean if you were as far north as we are here in Kentucky on Mars, it's not going to be 76 degrees. That 76 degrees would be around the equator. So if you were going out and traversing across Mars, would you get cold? Tendency on Earth, if you were out doing some things out on the Earth, you would want to build a what? where you think you would want to build. So think about if you've ever been out camping, right? When it gets cold at night, you want to build a what? So we're talking about going out and walking across the surface. So you're not going to have the stuff to build a building. That's a good idea. A fire. That's what I was looking for, Will. Would you be able to build a fire on Mars? If you say yes, raise your hand on your video so I can see you. If you think you could build a fire on Mars, any yeses? If you think no, raise your hand. Because a fire needs what? Gotta have some what? Oxygen, right? You're not gonna have that. You're not gonna have that oxygen on Mars. So if you were going out and walking across Mars, that would definitely be something that you would have to figure out. How would you keep yourself warm? A suit, obviously. So the spacesuits that they design keep astronauts not just warm, but it keeps them cool too. So you would have to figure out a way to keep yourself warm. Now, how long do you think it would take you to get there? So if you were going to be an astronaut, look at that distance. We'll look at the miles because that's what we're used to here. Almost 142 million miles away. Any idea the range of time it would take to get there? Obviously, it would be dependent on a few different things. Any ideas? Oh, Eli, a little longer than 108 hours. Good guess, though. 6 months, 1 to 2 weeks, a few months, I see. Maybe a year, says Chanel. So a mission to Mars, depending on where Mars and Earth are in their orbit, can take anywhere from 6 months to a year. So you would be on a spacecraft anywhere from 6 months all the way to a year just to get there. Do you think that you would stay just a day or two if it took you that long to get there? Probably not. You'd probably be staying for a while, right? But then, depending on where they are in their orbit again, it's going to take you that long to get back. So if you were going to be an astronaut going to Mars, think about the time commitment just to be gone off of the Earth. Could possibly be 2 years just travel time, getting there and back. And then depending on how long they want you to stay there, do you think things would be different when you got back? Think about technology, how fast it changes. How many of you have a phone, like an iPhone? Do you think your iPhone would be obsolete by the time you got back? Would it be a little different? Think about how many of those come out every couple of years, it seems like, or maybe even every year we're going to have a different phone. Yeah, a lot of you say yes. So things would be very different. So those are things that astronauts have to think about when they're going and hopefully going to Mars. But we're going to get into, in this endurance book, a little bit more the further we get along, why it was important for Scott to do that long duration mission on the space station. So if you remember, he was up there, if you haven't gotten that far yet, he was up there for about a year because we're doing lots and lots of testing. So you'll learn a little bit more about that as we go. Now, how many moons are there? How many moons? Does it have one? Does it have two? Does it have a few? Two, you got it. Yeah, there are 2 Mars moons. So those moons, they have names, actually. Do you know their names? The bigger one is called Phobos. So look at that picture of it there. Phobos. And then the smaller one is Deimos. Does that look like our Earth's moon? Look a little different, right? So what they think these moons actually might be are asteroids that have been pulled in by Mars's gravitational pull. And so the idea is possibly, maybe in the future, to actually station maybe like a mission control on one of those moons so we wouldn't have to go as far back and forth. Yeah, one kind of does look like a peanut and the other one does kind of. They're not round at all, but there you can get some size differences there. How cold it could get, if there's an atmosphere, things like that. So Miss Melissa's going to be going over a lot of these facts with you again, but one of the big activities that you guys are going to be doing is going to be about rovers. All right, so for next week, now you don't have to have anything physically handing any paper or anything physical to Miss Melissa. These are just some things that we want you to think about before next week's meeting and maybe look up and get some information about. First of all, what a rover is, right? And then we want you to figure out how many rovers have been sent by the United States to Mars. So how many rovers have actually been sent here from the United States to Mars, and how many of them are currently sending data back? So are they all still working or not? So that's what we want you to find out. Find out a little bit more information about the rovers that are up there. And bonus, if you'll be able to tell what Miss Melissa what this thing is in this picture that kind of looks like a lightsaber. It is not a lightsaber. But that'll be a bonus. We'll send that to you in an email, that little picture right there too. So
It
before
looks
next
like a
week.
screw or something.
It does kind of look like that, Elliot, but we're going to see if you can figure it out. So for next week, you're going to see if you can tell us how many rovers have been sent, how many are still working. All right, don't tell us that yet. Miss Melissa's going to ask you all that between now and then. So just a reminder, our next meeting will be next Thursday, in-person meeting. All right, so hopefully we'll see you guys all then. So until then, have a great rest of your week. And I'm sure most of you have a 3-day weekend. So enjoy that, guys. So I think probably some of you will be out of school on Monday.
Hey,
So
Miss
bye,
Jennifer.
guys.
Bye.
Thank you. Bye, guys.
Miss Jennifer,
Uh-huh.
Bye.
you wanna know an interesting fact?
About?
John Glenn Jr.
Oh, sure.
So when that mission launched, my stepdad was actually part of he was in 5th grade. And he got to watch the rocket launch in Florida.
Oh, wow. That's awesome. So he's actually been down and got to see a launch. That's pretty cool. Yeah, not a lot of people can say they've done that. A lot of people I know have gone down to watch a launch, but they don't always get to do that. So awesome. All right, guys. See you next week.
See ya. Bye.